Alright, so this is chapter 4G of measurement here, and today we are going to be covering the surface area of prisms. Now, just before we get into that, I just wanted to go over some of these do now activity questions, pretty much like a start activity just to get you settled in, but this will pretty much cover what we did last lesson. So the first question is, what is the formula for finding the area of a sector? So if you remember from last lesson, the formula would be A is equal to angle over 360 degrees times pi r squared. Now, question two, find the area of the following sector. So just looking at this little thing right here, I've got an angle of 120 degrees and I've got a radius of 9 centimeters. So just to clarify, there's only two things you need to find the area of a sector. That's the internal angle here and the radius, okay? So I'll just write theta is equal to 120 and then r is equal to 9. Now I'm just going to use my formula and substitute in my values, okay? So A is equal to 120 degrees over 360 times pi times 9 squared, okay? And if we type this exactly into your calculator, uh, uh, no, stop. There we go. 120, 360 times pi times 9 squared. Okay. So I end up getting 27 pi. Now, if the question asks you to find this area in exact form, you'd leave it exactly like this. But if they ask you to find it in two decimal places, just press that funny double arrow button and turn to 84.82 centimeters squared. And that is after rounding it. Okay. So the goal is to know the meaning of these terms here. So you have prisms, net, and total surface area, and to find the total surface area of a prism. Now, one thing you need to know, okay, the difference between 2D and 3D is a 2D shape is mainly made up of length and width, and a 3D shape is made up of length, width, and height, okay? So you don't need to write this down. It's perfectly fine. All right. So what is a prism? A prism is a 3D shape made up of multiple 2D shapes with a uniform cross section. Now, you might be asking, what's a cross section? A cross section is technically like when you cut through the 3D object, okay? The two pieces that separate will be identical, okay? So if you have a look here at this example, I've got a picture of a cube. And if I were to get a knife and cut in the middle of that, I'll get two separate pieces where it looks exactly like a square, okay? So that's all you need to know. All right, let me see if I can fix this. No, let me zoom in a bit. Perfect. Now, there are three things that make a prism, okay? So you have the faces, the sides, and the base, okay? So this is really important. So the bases can be any polygon, aka any 2D shape. So something that you'll typically see is like a rectangle, a square, a triangle, stuff like that. Um, the sides are always rectangles or parallelograms. We'll get into that in a moment. And the face is any 2D shape all over the prism, okay? Um, Now, it would be nice if I was there in person because I could actually bring in the box and show you. But actually, let me see if I can find it. Couple row. So yeah, if you have a look at this toggle right here, as you can see, it's like triangular and it's like really long, right? Actually, let me see if I can copy this picture. Right. Oh no, that's not what I want. Oh, oh, there we go. Okay, let's have a look here. So, looking at this Toblerone picture, what we're describing here is so the base can be any polygon shape. So, in this case, just looking at this Toblerone itself, this right here that I'm currently highlighting in red, okay, this is technically the base. Because remember, the base is any polygon 2D shape. It's just like that. Or it can also be a face. So basically, what it's like is like this prism is made up of many faces, so any 2D shape all around, right? So that could include this section, it could include this purple section. It could even, if you look at it from a different perspective, it'll cover this side as well. And if you think about it, the bottom of this bubble run as well. So that's what a face is, okay? It just covers everything. Now the base is just the bottom of it, okay? Just think about it that way. And the most important, so I can call this the base. Now, as you can see here, the sides are always rectangles or parallelograms. So the side that I'm currently shading in purple is called the side, okay? Like it'd be nice if I could bring in like a diagram if I was there in person, but it is what it is, you know? But yeah, like I'll make sure to make it up to you or next time. And then the face is just everything like what I explained earlier, okay? So yeah. So another thing you'll need to know is how to name prisms, okay? So most importantly, the prism is named after the shape of its base, okay? So whatever the shape the base is, you would call it that specific 2D shape and then add prism to the end, okay? So over here, I have a triangular prism. It's called that way because it has triangle bases, okay? And a rectangular prism has rectangle bases. So just referring back to our Toblerone here, as you can see, we have a triangular base. So we just call that a triangular prism, okay? So yeah. Now, this is what a net is. I'm pretty sure you've all experienced this since primary school. But you might remember the days where your teacher might have given out scissors and pieces of paper and you just had to cut around it. And he had like glue stick to stick in like once you fold up this net here, it'd make like a pretty cool three-dimensional shape, yeah? So that's just what a net is. A net is just like a 2D representation of all the faces, okay? Like on the solid. So a solid is just a 3D shape. It's another word for 3D shape. Oh, that spells from. Ooh, let me fix that. For. Yeah. So yeah. Um. Now the main juicer. Okay. So very important. You need to find the total surface area. So when what I've been teaching you is finding the area of 2D shapes, but you are now going to find the area for 3D shapes. So that is the main distinction. Okay. And it's even mentioned here. It's when you add up all the areas in the faces. So if you think about it, a cube, it has the front, it has the base, it has the top, and it has the three other sides around it as well. Yeah. So basically, you are going to find the area of those squares and just add it up all together. Now, the quickest way to find the total surface area of this cube is because we know that the area of a square is let me just fix this up. It's just length times length here, which is the same thing as L squared. We just multiply this by 6, okay? So that's all it is. So that's the quick way over there. Now for a rectangular prism, same thing. You're going to find the areas of all of these faces and then add them up. So you'll find the area of the front, which is length times width. You're going to find the side here, which is W times H. And you are going to find the area of the top here. So the top is, what is it now? No, that's the same. Hold on. You'll be finding the area of the back. So, wait, no, pause. So this is the base, this is the side, and then you're going to have the the area in the front, okay? So it will be length times height. Now, if you think about it, just looking at this diagram, as you can see, you got the front side, and then you got the back side here. So there's actually two of those specific areas that you'll be finding. So just make sure you put a 2 in front, just like that. And then for the side, width times height, you got the side there, but you also have the side here. So that means you also need to multiply this by 2. And vice versa, you got the bottom and the top there, okay? So you sort of get the gist there, okay? Um, I've done it in the wrong order. But yeah, overall, if I were to rewrite this, it would just be 2LW plus 2WH plus 2LH. Now, don't get too confused, okay? If I were to write it out properly, uh, uh, oh, my screen's frozen. So for this example here, um, we have the surface area of this rectangular prism. So just start off by labeling like, well, there are two ways you can do it. You can find the area of each of these little rectangles here individually, including the top and the bottom. Or you can just use this formula here, which I have provided from this slide here. Okay. So because we know this is a rectangular prism, we can just use our formula of TSA equals to 2 length times width plus 2, what's it called? Width times height plus 2 length times height. Okay. So let's just start off by writing out what our length is going to be. So I know this 3 centimeters is my height. I'm just going to call my 7 centimeters the length, and then I'm going to use my 10 centimeters as the width. Now, it doesn't really matter which one you label the length or width, because when you multiply them all up, all the height, once you like do the following calculations, it always ends up being the same. So I'm gonna do 2 bracket, what's length times width? 7 times 10 plus 2, 10 times 3 plus 2 bracket 7 times 3. And it'll end up looking like this. 2. Now just remember your bin mass rules, okay? Always do the brackets first. So 7 times 10 is 70 plus 2, 10 times 3 is 30, and 7 times 3 is 21. Now you might be confused as to what happens here now. Now, over here you don't see an operation, right? But there's technically an invisible times right here in the blue, okay? So this technically means 2 times 70 now. So 2 times 70 is just 140, 2 times 30 is 60, and 2 times 21 is 42. And if you just add that all up, you should get, let's see, 102, 102, 242 centimeters squared. So that's what the total surface area of this rectangular prism here is, okay? Now over here, in this example, I have a triangular prism, okay? Now, I don't know what the formula is on the top of my head, but I do know that we can just find the area of all of these faces, and then we can just add them all together at the end. So I can see that there's two triangles here. So where the front is and the back, I also have some rectangle lying here as the bottom, which includes the 6 and the 15. I have another rectangle that's going the slanted way down. So that's the slanted way. And then you got like the back rectangle as well. It's hard to color these in. So you just got to look at it and recognize it pretty much. But we'll start off with the two triangles, okay? So to find the area of a triangle, the formula was base times height divided by 2. So I know the base is 6 and I know the height is 8. So I'm going to do 6 times 8 divided by 2, and that should just end up being 24 centimeters squared. Now, because of the fact that there's two triangles, I need to actually multiply this by 2. So I'm just taking that into account as well. So that means the total surface area for the two triangles so far is 48 centimeters squared, okay? Now, with that out of the way, I am now going to find the area of this little rectangle at the bottom here, okay? So that bottom rectangle will just be um, 6 times 15, length times width, just remember that, which equals to 90 centimeters squared. So that one's done. I should probably write it in purple. Mhm. Now I am going to find this little rectangle that's slanted, okay, or the yeah, that little slanted rectangle there. So I'm just going to do A is equal to length times width, which equals to 15 times 10, which is 150. So just like that. And the last color I'll use as green, and you are going to find the area of the back rectangle now, okay? So, so the back rectangle is length times width again, but it now becomes, let's see, now becomes 8 times 15, which is equal to 120 centimeters squared, okay? After that, you just add up all the areas and you should end up with So I'm just going to write it on the left here, TSA, which equals to 48 plus 90 plus 150 plus 120. If you add that all up, you should get 270, 360, 408 centimeters squared. Okay. Give you some time to work on this. I'll just make a separate slide showing all my solutions and then we can just go from there. Okay. Just give me a moment. Alright, so this is the solution for the first rectangular prism here. As you can see, I've just used the formula. Now I've just labeled my length, width, and height accordingly to whatever I think is right. I think the height is the easiest one that you can consistently point out, but the length and width, it doesn't really matter that much, okay? So if you just substitute the numbers in and you just apply this formula, type in your calculator, yada, 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 you should end up with 108 centimeters squared. Now, as for my triangular prism here, um, there are some quirks that you should know. So something to note are these dashes here. So that means here we go. This diagonal line and that one are the same length. And I also noticed a third one as well. So this plays a big part into some of my calculations. So as you look at the area slant, okay, so for the rectangle, I did the traditional area of a rectangle, which is length times width, right? And I substituted the numbers in. But because there are two rectangle slants and they are of the same measurement, that's why I've included this times 2 at the end there. So I found out what the area of my rectangle is normally, and then I just multiplied it by 2 after. That's why I got 100 centimeters squared. Now, in my area of my triangles, which is the front and the back, I've added this times 2 here because there are two triangles that are of the same measurements, okay? That's why I've done so. But yeah, so these are the questions you have to do. Good luck, have fun, okay?